Alright guys, this is lesson 7.2, exponential decay functions. So before we were doing exponential growth, which is the basic exponential function, now we're going to do decay. So when we look at our decay function, it's going to be the exact same as our exponential function that we learned about last video. So I still have a times b to the x minus h plus k. Now, the only thing different about the decay function is that b is going to be a fraction. So, b is a fraction. So that means that b is going to be less than 1. For example, something like 2/3 or 1/2. Now, our decay function is going to look like this. Our asymptote is still going to be at 0, but the difference is before our exponential growth function went this way. Now our decay functions are going to go this direction. We're going to end up having our arrow going towards the positive direction. Okay, things that we need to remember when graphing exponential functions or decay functions. This is going to be the same thing as before, 100%. So we are going to plot 2 points. So we're going to have our y-intercept, which we find by saying x is equal to 0, and then we're going to plot another point. Now, the thing that we need to remember is that sometimes we can have negative, or we can make our exponent or our x value for our other point negative. So negative exponents can be helpful. Okay, so let's practice with this first example. We have y is equal to 4 times 1/5 x. First thing I'm going to do is set my x value to be 0 for my y-intercept. So I have y is equal to 4 times 1/5 to the 0 power. Anything to the 0 power is 1. So I have 4 times 1, which is 4. So my first point is going to be 0, 4. I'm going to be at 0. I'm going to go up 1, 2, 3, 4. So my first point is going to be right here. Then I'm going to set, in this case, x equal to 1. So I have x equals 1. So I have y equals 4 times 1/5 to the first power. And anything to the first power is just that number. So I have 4 times 1/5. And if I wanted to rewrite this, I could write it as 4 over 1 times 5, or 1 over 5, sorry, times 1 over 5, which is equal to 4/5. So my next point is going to be 1 and 4/5. So I have 1, and then 4/5 is not quite 1, so it's going to be here-ish. And now my asymptote is still going to be at x equals 0 because I have plus 0 as my k. So now I'm just going to draw in my graph. So it's going to be this way, and I'm going to come down through my point and snuggle my asymptote, and it's going to look something like this. Okay, now let's look at our domain and range. Our domain, I'll use a different color. My domain is my x values. So my domain, it's going infinitely this way and infinitely this way for x. So my domain is all real numbers. And my range, I have my asymptote at y equals 0. So my range is going to be y is greater than 0. But it's not equal to 0 because it never actually touches 0. Okay. Next example, we have y equals negative 3 to the 3/4 power to the x minus 5 plus 4. So I'm going to do the same thing as I did before. I'm going to ignore h and k to start with. Remember, I'm only going to graph the y equals ab to the x power. So I'm going to set x equal to 0 so I can find my y-intercept. So I have y equals negative 3 times 3 over 4 to the 0 power. And remember, I'm only graphing y equals a to the b, or a times b to the x. Anything to the 0 power is 1. So I have negative 3 times 1, which is just equal to negative 3. So my point is 0, negative 3. So 0 and then down 3. So I'm going to be right here. Then I'm going to pick another point. Now, I'm going to pick a negative exponent just so I can show you how it's helpful. So if I set x equal to negative 1, now I'm going to have y equals negative 3 times 3 over 4 to the negative first power. Now remember, my negative 1 power for my fraction flips my fraction. So now I have negative 3 times 4 over 3. So I'm going to end up with negative 4, because this also could be negative 3 over 1 times 4 over 3. So my 3's are going to cancel, and it's going to be left with 4 over 1. Now, this point, negative 1, negative 4, is going to be a lot easier for me to graph. So I have negative 1 and then down to negative 4. Now, if I would have chose a positive number, it would have been fine. I would have had y is equal to negative 3 times 3/4, and it would have given me negative 9 over 4, and so I would have just had to graph 1 and then negative 9/4. Now, this is totally fine. You can graph it like this. It just helped me using a negative exponent in this case because then I got whole numbers. Okay, now I can do my h and k part. So I'm going to draw in my graph, and remember my original asymptote is going to be at x equals 0. Woo, that was not good. My original graph is going to be at x equals 0 right here. So I have my graph going like this through both of my points, and then it's going to hug my asymptote. Okay, now I'm going to look at my h and k. First thing I'm going to do is my h. So my h is going to be negative 5, which means I'm going to go the opposite direction, so I'm going to move to the right 5. So 1, 2, 3, 4, 5 for this point. And then 1, 2, 3, 4, 5 for here. So now my next graph looks like this. And then it's going to go up to my asymptote, and it's going to stop at x equals 0, or y equals 0, I'm sorry. And now I'm going to scooch up 4. So my red point is going to go 1, 2, 3, 4 and be right here. My blue point is going to go up 4, 1, 2, 3, 4. And then my asymptote is also going to go up 4. And remember, my asymptote is located where k is equal. So my asymptote is now going to be right here. And so my graph, my final graph, is going to look like this, and it's going to go up and eventually snuggle my asymptote. So this one right here is my final. Notice that we are doing the exact same thing that we did last time. We just now have graphs where our final arrow is going the positive direction instead of our asymptote. Yes, it's going towards the positive direction instead of the negative direction. All right, now for our last example, our word problem. We're going to use the exponential decay model. Okay, so I have y equals a times 1 minus r to the t. I'm going to need you to memorize this formula. This is going to be our formula for our exponential model every time, where a is our initial amount, r is our percent decrease as a decimal because now we're doing decay, and t is our time. So our question says, the value of a snowmobile has been decreasing by 7% each year since it was new. After 3 years, the value is $3,000. Find the original cost of the snowmobile. So I'm going to be solving for my a value. So I have my y is going to be equal to $3,000 because that is my ending value. Now my r is my percent decrease. So my percent decrease is 7%, or if I was going to write that as a decimal, it would look like 0.07. And my time is going to be 3 years, which they told me. So now I'm going to put this in my equation and solve for A. So I'm going to have 3,000 is equal to A times 1 minus 0.07 to the third power. So I have 3,000 is equal to A times 0.93 cubed, because 1 minus 0.07 is 0.93. So now I have 3,000 is equal to A times 0.804357 if I don't round it. Now I'm going to divide both sides by that decimal. So I have 3,000 divided by 0.804357. Same with this side. I'm going to divide by 0.804357. So I can cancel these out, these two pieces. So now I'm left with 3,000 divided by 0.804357. So my A is going to equal 3,729.69. So my initial amount for my snowmobile was $3,729.69. I will see you tomorrow ready to do homework.